You are welcome. Here is a physics question. Uh, is it a force of 20 Newton is applied to a spring of elastic spring constant of 200 Newton per meter. So calculate the energy stored in the spring. So if you want to calculate this, you have to calculate the energy stored in the spring. So you know that the energy stored in the spring is the same thing as work, which is half over what k is squared. So this is what the elastic constant, and then you have this one as what the extension. Then here you are given the force and what and the elastic constant. Then you have to know the value of what the value of extension. So you know that force is what that is proportional to what uh, to the extension. That is the extension of what of an elastic material is proportional to what the applied force. So what you have here is force, which here the force here is 20. That's 20 Newton equal to K. So you have K times the value of K here, which is referred to here as what constant. So you have it as 200 Newton per meter. So as this one is Newton multiplied by K E. So here this one will give you this. So you divide both sides by what 200. So you will have 20 Newton divided by 200 Newton per meter. So this cancel this. You have this. So here what you have here is 10 is 1 over 10. Then E equal to what? 0.1 meter. So the extension now is what? 0.1 meter. So then you want to calculate the energy stored in the spring. So the energy stored in the spring is is 1, that's half times what? That's constant, which is 200 multiplied by what? So the extension. So the square of the extension. So that's it. So you have this equal to what? So this cancel this. So you have 100 multiplied by 0.1 squared. So 0.1 squared is what? 0.01. So if you multiply it together, you are going to get 1. So that's 1 joule. So that's the energy stored in the spring. That's the energy stored in the spring. Then that's the first question. So look at the second one. The question is from uh, one Posuemi of OAU Posuemi. So you have this one say the reading of ADE temperature at the ice melting point is 40 degree. That's 40 degree A and 80 degree at what steam point. Calculate the reading on the Celsius scale equivalent to 50 A. So for this one, so you know that. So if you have the ADE scale like this, so you have the steam point. The steam point they say is 40. Then I mean the melting point is 40, and then the steam is 80. Then you have to calculate the 50 degree equivalent. So here is what? So let's say 50% is here. So you have 50% equivalent. So A. Then here you want to use Celsius scale. So the Celsius scale, you know that the steam here is what? 100 degrees Celsius. Then here is 0 degrees Celsius. So you want to calculate the equivalent of it here. So you can simply put X there. Then now So you want to calculate it how? So this minus this, so you have it like this: 80 minus 40. I think 80 minus 40. So 50 minus 40. So it's equivalent to 100 E, that's 100 minus 0. Then x minus what? 0. So what you have here is 40 over 10, which is equal to what? That's a 100 degree over x. So if you this can cancel this, so you will have 4 over 1 equal to 100 degree over x. So if you cross multiply, so what you have here is 4x equal to 100 degree Celsius. So you divide both sides like this. So in this case, what do you have now? In this case, you will have 25 degree Celsius. That is 50 degree Celsius in ADE scale is equivalent to what? 25 degree Celsius.